got another polynomial up here. F of x equals x to the fourth minus x squared. And once again, I want to graph this. And I want to use the zeros of the function to break the x-axis up into intervals so that I can test to see where my graph is going to be positive, meaning that the graph is above the x-axis, and where it's negative. Now this time I didn't give you the polynomial in factored form, so I'm going to have to factor it. Now I notice that I just have two terms, and there's a greatest common factor here of x squared. These are both just powers of x. This is 4 factors of x, that's 2 factors of x. They've both got at least 2 factors of x, so I can pull that out. If I do, that's multiplied by x squared minus 1. I'm basically viewing this as the result of distributing x squared to each of these terms. So factoring, when you're factoring out a greatest common factor, is just undistributing it. And I can always double check. Did I do this right? Let's see, if I distribute it back, x squared times x squared would give me my x to the fourth. X squared times minus 1 would give me my x squared. Okay. Now, that's a good first step, but I'm not done, because I can factor this even further, because this is now a difference of 2 squares, because 1 is 1 squared. So this is going to be x squared times x plus 1, x minus 1. So if I look at my zeros, which are just the x values that make this thing equal 0, I need to look at each factor. That's going to be 0 if x is 0. This will be 0 if x is negative 1. And this will be 0 if x is 1. So if I create a number line here, I can mark off negative 1, 0, 1. Do be careful. The order in which I found them here is not the same as the order in which they occur on the number line. And that breaks my number line up into 1, 2, 3, 4 intervals. And what I know is that these are the only locations where my function could change sign. So the function is consistently either positive or negative on this entire interval. Consistently either positive or negative on this whole interval, etc., etc. And to check that sign, I find it helpful to just check each of the factors, and then I can check the final result. Okay. So if I pick a number to the left of negative 1, I might pick negative 2. Okay. Now x squared, I can go ahead and fill in. That's always going to be positive. The only time it's not positive is when it's 0, and that occurs here. On the intervals in between my zeros, it's always going to be positive. But x plus 1 I need to check. Negative 2 plus 1 would be negative. Let's see, negative 2 minus 1 would also be negative. So here I've got a positive times 2 negatives. That's going to make f positive. Between negative 1 and 0, let's see, this is positive. I'm going to choose, let's just choose negative 1/2. Now, I had to choose a fraction here, but that's not the end of the world, because negative 1/2 plus 1, I can tell that's going to be positive. Negative 1/2 minus 1, that's going to be negative. Okay. So I've got 2 positives and a negative, so that's going to give me something that's negative. Okay. Between 0 and 1, let's pick a half. Okay. 1/2 plus 1 would be positive. 1/2 minus 1 would be negative. So I've got 2 positives and a negative. That's going to be negative. Okay. And then bigger than 1, I can pick 2. 2 squared is positive. 2 plus 1 is positive. 2 minus 1 is positive. And a product of 3 positives is going to be positive. So it looks like my function changes sign at negative 1 and at 1. At 0, it doesn't change sign. It was negative, it's going to touch 0, and then it's going to go back down and be negative again. Okay. So if I go to graph this, the zeros give me the locations of my x-intercepts. So I'm going to have a point at negative 1, 0, at 0, 0, and at 1, 0. Now notice in this case, because we go through the origin, we've actually plotted the y-intercept as well. For any function, I can always ask you to graph the y-intercept. You would find that by simply plugging in 0 for x. Notice if we do that, we get 0, confirming that yes, that point is on the graph. All right, now this this says we've got to start positive. We're going to cross the axis at -1 to become negative. Between 0 and 1 will be negative as well, but we've got to come back up to 0 in between, and then we'll cross back up to be positive. So it looks like we're going to get some sort of a W shape here. Let's make sure this is nice and rounded. Like so. Now, there are a couple of things that I can check. First of all, I know that these 3 points are accurate. Let's just double check our end behavior. Okay. Now, I'm just double checking to make sure I didn't make a mistake. If I did this right, that graph is right. Okay. But notice my lead term is x to the 4th. Well, that makes sense. As we go off to whether it's infinity or negative infinity, that is going to go to infinity. Now, one thing I don't know is how low these points are. All I know is that my function is negative between -1 and 0 and between 0 and 1. I don't know how low it goes. I could, if I wanted to, try plugging in some points to plot things and try to guess how low we're going to go. I'm not going to bother because that's kind of tedious, and because in calculus you will learn a much more efficient way for figuring out how low those low points should be. And when you have high points, how high they should be. That's something that calculus is really good for. With pre-calculus, we can get the general shape of the graph, but we don't have the skills to get exactly how high or low our maxes and mins are, unless they happen to be like this one at the origin, at a place where the y value is 0, and we were plotting those points anyway. Okay, I can confirm, though, that however low this point is, this point should be just as low, that they're a mirror image. I am suspicious that this is an even function. I've graphed it so that it has symmetry. Let's double check. If I were to plug in the opposite of x, because remember that's how I test for whether a function is even or odd, this would become the opposite of x to the 4th minus the opposite of x squared, but those even powers just kill off those negative signs. So that's x to the 4th minus x squared. That's the same as f of x. So this should be symmetric about the y-axis. Kind of neat to see that. Okay. All right. So there we've got another graph. I'm going to actually stop the video, but I'm going to continue with this example in the next video because I want to take a look at another way that we can get the general shape of the graph.